fantastic. Okay, so the first thing that I want to do, is I want to go over the question of the day. Okay, so Jesse, what did you get for the question of the day?
I put 24.
24 ohms.
I divided.
That's what you did, right? Because we have the triangle, right? Voltage, and then we have our current, and then we have our resistance. And the only thing you do is you figure out where it's at, put it in here. If it's here and here, you divide. If it's here and here, you multiply, right? Very simple question. But now what we're going to do is you're going to go a little bit longer way than the simple task that we had before. So the answer to that question, like Jeff said, was 24 ohms. Okay? So that was the question of the day. So those of you that are at home, what you have is you have a picture of this poster that I've made. So we're going to kind of go over the picture first. After we go over the picture, and this is going to be the second part of the introduction to electricity. And after that, we're going to go over a section of just series by themselves today. So the first thing we want to know is we have to know what the symbols are. So the symbols are V for voltage, okay? We have I is our current, and it's measured in amperes, which we're going to use the letter A. Resistance is R, which is in ohms, which is this funny-looking horseshoe, okay? You'll need to know those. You'll have to memorize what those variables are. And then the next thing that I have here is where I drew a schematic. And then what that is, a schematic is just a drawing of electricity that kind of tell us what's going on. If you look here, we have where we just have a battery. It's a 6-volt battery. We also have a resistor, which is 150 ohms. And we don't have a light bulb. If we had a light bulb, say I'm going to have a light bulb, we would put it right here. Okay, that would be also some kind of power taken away. And as you can tell, this here is just a series circuit. First thing we want to talk about is the two different types of circuits. So the two types of circuits is we have a series. A series is all in a line. If you look here, we have our voltage, we have our resistance, we have our wires that go along. Some of you at home yesterday was working on your circuit builder, which we're going to work on a little bit more today. And you would have to be able to go here and then put your amp meter where you need to have it. Series is a total resistance. Current flows from each component. You have your I total. Remember, your I is current. And your current is where you just add them all together. Voltage, same thing. You just add them all together. And then you use the Kundov voltage law to prove that you're right. So if you look over here, the voltage law is the sum of all the voltage dropped in the series total the applied voltage. That's what we're going to do over here today. The next type of circuit is a parallel circuit, which are actually going to have, as you can tell, they're not all in a series. They're actually down another path. The current flow of each, your I total is your I1, 2, and 3. But your voltage, you have a different type of math, which we'll go over tomorrow. Here is a schematic of what a parallel circuit looks like. For a parallel circuit, you do something different. You do the same thing for your current, but here for your resistance, you have to do a different type of math for that, okay? So what we're going to do is we're just going to go over one circuit today, and we're going to do just the series circuit. So here I have a plain circuit, which I have a 12-volt battery. It goes through the first resistance, which is 2,200. My second resistance is 4,700. And then my third one is 1.2K. Now, if we wanted to change that, which we're going to change in the math here, you would have to make sure they're all equal, okay? So here we are, total resistance. R1 plus R2 plus R3. As you know it, we changed it for here to ohms. To do that, you drop a 0. So in your calculator, if you would, take 220 plus 470 plus 1,200. Because what I did is I changed the 1.2K to just my ohms by itself. So open up your calculator on your computer and type those in and see what answer you get. Hey, where's your computer?
I'm not doing
Oh, open it up and open your calculator up, please. So Hugh, what did you get for yours?
For what?
For your resistance total. So what I asked you to do is just take the 200 plus the 470 plus the 1,200 on your calculator, please, ma'am, sir. What do you get?
That is a 12 at the end, isn't it?
It is 1,200. What I did is I changed the
Oh.
1.2 kilo ohms to just ohms. I'm asking you because I only have two other girls here, and I'm going to be asking them questions too.
I got 1,890.
Okay, so 1,890 ohms. And what I did here is I changed this to kilo ohms. To do that, I just moved the decimal over, which is 1.89 kilo ohms, which is my total resistance. So the first thing you're going to do when you're doing a series, the first thing you have to do is find the total resistance. Okay? The next thing you have to do is you have to find I. And remember, I is current. So now what we're going to do, we're going to do this total for your current equals your voltage total over your resistance total. So we only have one battery, right, Kate?
Right.
How many voltage is that one battery?
12 volts.
12 volts. So I took the 12 volts and I divided that by my resistance total, which is right here, right? And I got, and do that in your calculator, please. On that, do your alpha y equal when you do this fraction. We're doing 12 over 1.89. What do you get, Kate?
I'm sorry.
It's okay.
I've got 6.349206349.
Correct. All right, so that is my current for each component. My dyslexia today, guys. I did on the wrong one first. Okay, so so that's our total current. So the next thing we have to do is we have to find our voltage that runs through each circuit. So the first one, we are going to take our 6.3.49, which is our current total, right? And we're going to multiply it by our first resistor. Now, I took it from here and changed it to ohms. So if you would please, ma'am, tell me what you get on your calculator. Jesse? Yep. So you're just taking 6.349 and multiplying it by 220 ohms. What do you get?
And you multiply it times 220.
Yes, ma'am. So you're just going to take that, your current total, and multiply it by the first resistor.
1,396.78.
Fantastic. So write that down right there. So then the next thing you're going to do is you have to find your voltage too. We're taking the total current that we have, and this time we're working on this one right here. Okay? So I'll do that one. And the reason why we're doing this is because you're going to have to do these with the practice problems, and I want to make sure you know how to do them. 6.349, and I'm going to times that by 470 ohms, and I get 298403. Perfect. So Hunter, what am I going to do with the third voltage? I'm trying to find the voltage of how much voltage is going through this resistor. What would I do for that, sir?
total current times
Yep,
R3.
total current with the R3, and remember what we do is I put 1.2 kilo ohms down, but in reality, it should be 1,200 ohms, right? Because I want them to have the same unit. Sometimes when I do is I just come up here and I just change it here to remind myself, hey, that's what it's going to be, because I don't want to use different measurements.
Why did we take the extra zero off of the R1 and R2?
Because this right here is not ohms, this is voltage. And to be able to do that, we have to do the conversion where we take 1 decimal off. Because we only care about this place here. We don't care about this place.
And then the last one, we have to do it as 1,200.
Yeah, because the reason it is because this is kilo ohms, and 1.2 kilo ohms equals 1,200 ohms. Okay, so I'm just changing it to make sure that all the units are the same. What I would have done is I would have changed it up here and then wrote it through, but I wanted to show you how I changed it. But that was a good question. So if I take 6.349 and I multiply that by 1,200, I get 7.619, right? For my volts. Now for the Cundiff voltage law, I should be able to add all three of these up, and they should equal 12 volts. So let's take our numbers. 1.396 plus 2.984 plus 7.619, enter, and I get 11.99. What do you get?
Wait, what?
So what I did is I took this number, multiplied it by this, added each one. This plus this should equal 12 volts. Plus 2.984.
I've been tapping my calculators on.
It's okay. 7.619. And if you add those together, it should be very, very close to 12 volts. Yep. 984. It's okay. 1.396.
I got 11.999.
Yes. So it rounds up to 12. So what we did is we used the KVI, since this is a series circuit, to prove that our math is right.
Okay, so you add
Yes, ma'am.
total
Of all my voltage. So I'm taking voltage total equals voltage 1 plus voltage 2 plus voltage 3, and that should give me what I have up here equaling the other side.
Miss Sloan,
Yes, sir.
I was trying to take notes on that page there,
It's okay.
and on the series one where it has your resistance, I can't read the numbers on it.
Okay, so the resistance numbers that I have.
No, on
Or
the
two-
other page, the page you put on Google Classroom.
Oh, okay.
Can't read those numbers.
Okay, so I just did them I'll tell you what they are, but I'm going to tell you it doesn't matter. I was just showing you what they were. So like for the parallel, you got 470, 2.2K, and 3.3K for those three resistance. On your series, you have 122, which is my second resistance. My third is 133, and 181 is my first resistance. And those are just made up numbers.
You could just put R1, R2, and R3, and it would be enough.
Yeah.
Thank you.
Oh, you're welcome.
That's what I did. I just put the R1, R2, and R3.
Okay. So now what I want you to do is I want you to open up your FIT. Okay. So the FIT is on Mondays.
Okay, link.
Yes, ma'am. It's all separate. You got yours open? Let's go over to the lab itself.
Where's it at?
It is on Google Classroom. So what I'm going to do is I'm going to go here, and I'm going to open up Project Lead the Way. No, I'm going to open it up back here for y'all, so y'all can use it this way. So this might help today. What I'm going to do is I'm going to go into Project Lead the Way, and yesterday what the students did online, where they were supposed to open up 1 point. I'm gonna turn you around, sir. I don't know if you're gonna be able to see anything, but maybe you'll see something.
I think they can see me. Can you see me?
Hey, Kate.
Miss Dawn, they can see me.
Fantastic, I want them to see you. Okay. So those of you that are on at home, were you able to get on the virtual one that I asked you for? And girls, if y'all can turn around this way, just put it on the other side. Okay, so when you get online, YouTube for tomorrow, and those people that tried to do it yesterday, what you'll want to do is you want to go down to 1.23 simulation, physical simulation down here. Okay, so electric circuit simulation is where you're at. There's some notes, calculator, FET that you have to open up, and procedures. This here just basically tells you what symbols there are on there.
This is for tomorrow.
This is for y'all tomorrow. This was for them yesterday. Okay? And then here it has practicing simulations. So this here, one thing you're doing here is you're drawing schematic like we did here in class, and then you're doing your calculations like you did for your practice problem. Okay? So then if you scroll down after that, you see constructing circuits. That is where you have to open up your FET, and it tells us that we want to be able to construct the circuit display using the default bulb and switch in open position. Note that the circuit will look like the image below. You will interpret the schematic drawing and create a circuit, check the voltage across the light bulb. So the first thing you want to do is draw that, okay? In this thing. So you're going to open it up. So the first thing we have is a battery, right? So you just take it and move it. There. Then it tells us we're going to have an open circuit and a light bulb, right? So you're just going to get on here and you're going to play on it. So basically, I need to get a wire, don't I? So I'm going to take the wire. I'm going to pull it down. Well, I want this thing to be like this. I want this thing to look like that. Then you look at your picture again. So what I want you to do is I want you to try to use your computer and draw this circuit using this software. We're going to be using two different softwares. The first software is going to be the circuit construction with FET. And then after that, we're going to be working on using the other software that I have installed on your computer. Those of you that are at home, were you able to build these circuits yesterday and fill in this information?
No, ma'am.
Okay. I'm going to tell you, it takes practice on how to do it, but everything is here. What you just have to do is you have to figure out, all right, I'm going to put a wire here. Let's look at my picture. Go back up. And it's hard. Then I'm going to put another wire. Oops. Another wire here.
My light bulb works.
Yay. And I'm going to drag that down. I'm going to pull this over. You can make it bigger. There's a light bulb that goes right there, right, ladies?
You gotta have a switch.
We're gonna have a switch too.
Yeah, we
forgot
could.
to
Oh, I forgot the switch.
Oh my goodness, you forgot. I cannot believe you forgot.
I cannot believe it either. Switch. Oh, come here. I'm gonna cut that out. I'm gonna put that over here. I'm gonna put that there. I'm gonna put that. And it does, it just takes a moment to figure out how in the world.
Don't it keep going after this one?
Yep, but you gotta construct that one first.
I did.
And then, you already did? Let me see yours. Because mine, I'm still having issues.
How do you flip it? Oh,
How do you delete stuff?
something's on fire.
Cut it.
Oh no.
What is on, why do you have a
I
fire?
got one on fire.
Oh my goodness. You just go there and it should be, oh,
Why's it
You're
on
good.
fire, Miss Lou?
I don't have a clue.
Okay, you burned it.
Oh God.
And then it's asking for your voltmeter, right? You gotta pull that out. You're gonna put it where you need to put it,
No.
all right? And then you gotta see what it says once you go through and do a wire. Listen, I'm telling you, I'm not good. I promise you, I'm better with the other one.
Let me do it. I'm gonna do it.
Let's see if I turn the voltage up and make the fire dimmer.
This is not a game to play, okay? So those of you that are home, what you need to do is I need you to do 1.23. That's using this here, trying to do what you need to do. So all of this stuff here for use at home, you're going to have to go through this, make sure that you try to do these questions. This was from yesterday. Everything should be in your ISM book.
That's a long.
It is. It looks like it's long, but once you build it, it doesn't take long. And it's the math part. And then if you go to the next one, which is 1.24, I think is what I assigned you today. What if I did it virtual? What you're going to be doing here is you're just going to be doing the math.
So is that for us for Monday?
That's for you Wednesday and Thursday, correct. And this is what we're going to have to do on Wednesday. You're going to do it by yourself, and then you'll watch the video. Because what I'm going to be doing is I'm going to be giving them the answers. And we're going to go over this. If you get frustrated and you're like, oh, I don't know what I'm doing, then you can tune in and just do them with us. Those of you who are at home, how are you?
Confused.
At home, you're here. So my suggestion to you is to go back on here, try to build the circuits. I know it's fun, but the thing we're trying to do is we're trying to do the series calculations and also the parallel calculations. So make sure that if you're having a problem with the parallel circuits, just wait and we'll do those tomorrow in class. We're going to do some math on that one where I'm going to show you. Also, if you look at the PowerPoint, you're going to see that and how to do that. So see what you can do. What you're going to do at home, yesterday you did vocabulary. Yesterday you had to go on and you had to try to do 1.2.3. Today you're going to try to do 1.2.4. And then the girls here are going to stop in a little bit to finish their build. They'll have their build done. And then we'll go over 1.3 on Wednesday. Thursday, we're going to go over 1.4. And then we're going to go into breadboards where we're going to talk about how to wire those. And then we're going to be using another software to get that done by Friday. Those of you that are home, I'm going to go and stop the recording now. And I will put this link up for you in a little bit as soon as it comes through. And then we'll discuss it tomorrow. But try to do as much as you can do today. So when you get here tomorrow, we can just hit the floor running with what we need to do tomorrow. Okay? Questions, anybody from home?
No.
Okay, sounds good. All right, guys, we'll see you later.